Good afternoon, grade 6. This is the first Four Guys in a Math Cart math mini lesson. Our math mini today will cover how to use the RDW process to solve story or word problems. The standard that we are covering is 6, expressions and equations 7. And in this particular standard, the skill that is being covered is solving mathematical problems by writing and solving equations. Very important that you use your background knowledge and understanding to be able to understand this process. The first step in the RDW process is we need to use cube, C-U-B-E. C meaning circle the key numbers, U meaning underline the question, B means box any math action words. And what is an action word? Well, any words that gives you a key on what math skill you need to use to solve it. And then finally, E, evaluate. Now, what does evaluate mean? When you use the RDW process, meaning read, draw, and write, you are actually taking step-by-step process to understanding what the question is asking you. So first things first, let's begin with the cube process on a sample problem. Look at your math graphic organizer and identify the question and what it's asking. First step, let's annotate using cube. We're going to circle all of the numbers or math symbols that's in this problem. Take time to deconstruct the problem using annotation. Next, let's underline the question that's being asked. Now, I kind of made it easy for you. I identified the question. Find the solution or solutions and explain and support your solutions. So in this particular question, really think about it's asking you to do something and it's telling you what else you need to do. So it's really like two parts. You need to find a solution and explain and support. So when you go into your write, there should be at least two parts that's answered completely. Don't forget that. Now, let's box the important math action words. Think, equations. Think, choose, solutions, mathematical sentence, solution, another solution. This is basically an example of how we annotate, step by step, breaking it down to gain a true understanding. Now, after we have completed the cube process, let's go to RDW. Well, actually, we're on the evaluate, which is using the RDW process. Before we begin, take some time to gain some background knowledge.
When we're dealing with basic arithmetic, we see the concrete numbers there. We'll see 23 plus 5. We know what these numbers are right over here, and we can calculate them. It's going to be 28. We can say 2 times 7. We could say 3 divided by 4. In all of these cases, we know exactly what numbers we're dealing with. As we start entering into the algebraic world, and you probably have seen this a little bit already, we start dealing with the ideas of variables. And variables, there's a bunch of ways you can think about it, but they're really just values in expressions where they can change. The values in those expressions can change. So for example, if I write x plus 5, this is an expression right over here. This can take on some value depending on what the value of x is. If x is equal to, so if x is equal to 1, then x plus 5, our expression right over here, is going to be equal to 1, because now x is 1. It'll be 1 plus 5, so x plus 5 will be equal to 6. If x is equal to, I don't know, negative 7, then x plus 5 is going to be equal to, well, now x is negative 7. Negative 7 is going to be negative 7 plus 5, which is negative 2. So notice, x here is a variable. X here is the variable, and its value can change depending on the context. And this is in the context of an expression. You'll also see it in the context of an equation. It's actually important to realize the distinction between an expression and an equation. An expression is really just a statement of value, a statement of some type of quantity. So this is an expression. An expression would be something like what we saw over here, x plus 5. The value of this expression will change depending on how this, depending on what the value of this variable is. And you could just evaluate it for different values of x. Another expression could be something like, I don't know, y plus z. Now everything is a variable. If y is 1 and z is 2, it's going to be 1 plus 2. If y is 0 and z is negative 1, it's going to be 0 plus negative 1. These can all be evaluated, and they'll essentially give you a value depending on the values of each of these variables that make up the expression. An equation, you're essentially setting expressions to be equal to each other. That's why they're called equations. You're equating two things. An equation, you'll see one expression being equal to another expression. So for example, you could say something like x plus 3 is equal to 1. And in this situation where you have an equation with where you have one equation with only one unknown, you can actually figure out what x needs to be in this scenario. And you might even do it in your heads. What plus 3 is equal to 1? Well, you can do that in your head. If I have negative 2 plus 3 is equal to 1. So in this context, an equation is starting to constrain what value this variable can take on. But it doesn't have to necessarily constrain it as much. You could have something like x plus y plus z is equal to 5. Now you have this expression is equal to this other expression. 5 is really just an expression right over here. And there are some constraints. If someone tells you what y and z is, then you're going to get an x. If someone tells you what x and y is, then that constrains what z is. But it depends on what the different things are. So for example, if we said y is equal to 3 and z is equal to 2, then what would be x in that situation? So if y is equal to 3 and z is equal to 2, then you're going to have the left-hand expression is going to be x plus 3 plus 2 is going to be x plus 5. This part right over here is just going to be 5. X plus 5 is equal to 5. And so what plus 5 is equal to 5? Well, now we're constraining that x would have to be equal to 0. But the important point here, hopefully you realize the difference between expression and equation. Equation, essentially, you're equating two expressions. The important thing to take away from here is that a variable can take on different values depending on the context of the problem. And to hit the point home, let's just evaluate a bunch of expressions when the variables have different values. So, for example, if we had the expression x to the y power. If x is equal to 5 and y is equal to 2, then our expression here is going to evaluate to, well, x is now going to be 5, y is going to be 2, it's going to be 5 to the second power, or it's going to evaluate to 25. If we change the values, if we said x, let me do that same color. If we said x is equal to negative 2 and y is equal to 3, then this expression would evaluate to it would evaluate to, let me do it in there. So it would evaluate to negative 2. That's what we're going to substitute for x now in this context. And y is now 3, negative 2 to the third power. Negative 2 to the third power, which is negative 2 times negative 2 times negative 2, which is negative 8. Negative 2 times negative 2 is positive 4, times negative 2 again is equal to negative 8. It's equal to negative 8. So you see, depending on the values of these expressions, we could do even, we could do more complex things. We could have an expression like the square root of x plus y and then minus x, like that. If x is equal to, let's say that x is equal to 1 and y is equal to 8. Then this expression would evaluate to, well, every time we see an x, we want to put a 1 there. So we would have a 1 there, and you would have a 1 over there. And every time you see a y, you would put an 8 in its place. In this context, we're setting these variables. So you'd see an 8. So under the radical sign, you would have a 1 plus 8. So you would have the principal root of 9, which is 3. So this whole thing would simplify. In this context, when we set these variables to be these things, this whole thing would simplify to be 3. 1 plus 8 is 9. Principal root of that is 3. And then you'd have 3 minus 1, which is equal to 2.
Fascinating. Now that we have some sort of background knowledge, let's look at the particular question at hand. Think about what these equations mean. Choose one and find a solution. Write a mathematical sentence explaining and supporting how you know your solution is correct. Your three choices are x plus 6 equals 10, 100 equals m plus 99, or 1/2 p equals 8. Find a solutions, and explain and support your solutions. So in the R, first of all, choose which equation you would like to solve. Do that now. Next, what is the problem asking you to do? Write it out. And then finally, what background knowledge or math skill you think that you would have to use to be able to solve this. Identify it. The third aspect for your read now. After you have completed your read, let's go into draw. Now in the draw, remember from our previous lessons, you are to provide a math model and labels that will show how your plan makes sense. In this drawing, you're able to show your work and it supports your answer and is so detailed. Now detail is very important because should anyone look at your thoughts, it will make sense. At this time, please show your thinking in the draw. Let's begin the draw. Now, after we have put down our models to support our thinking, let's write out our answer. But it's also important that you know that this is a two-part question. Not only should you find a solution, but you need to explain your solution or support it. So, in the right, we make sure that we use complete sentences. So I can start off by writing my complete sentence by using part of the question. The solution to the problem is, and then you fill in the rest. You also complete the second part of the question by using the sentence again. You can say, my answer is correct, which is probably the lowest level, or you can say, my solution is supported, and then fill in the rest. Supported by. Once you have put down the complete sentences and you made sure that you've answered both parts of the question, the RDW process is complete. Thank you.